Hello again, everyone. It's Bob Martin, the RCSubGuy with the NautilusDryDocks.com, and I want to share with you yet another project. This one is very unique. It is a French hunter submarine. So this particular boat was commissioned as a scratch build by a customer in California because he had a particular affinity for this very unique boat. It has been rendered in 1/32 scale, making it about 61 inches in overall length. This boat is the Argonaute, which is an Argonaute class submarine, and like I said before, it's called a hunter submarine when you translate it from French. It was designed for quick maneuverability in the Mediterranean Sea as an anti-submarine platform. It's highly maneuverable, and you can see there's a lot of really excellent indications of that in the configuration of the stern of the boat. Argonaute was launched in 1957, and it was actually turned into a museum boat that you can go see in 1989. Now, this hull was actually 3D printed from files that were given to me by Matt Thor, who worked with this customer previously. But this is not your traditional filament printing. The entire hull was done in high-strength resin on a high-definition printer. It's a very, very robust and should be much stronger overall than a standard filament print may be. The tower, however, was supplied to us and is fiberglass. After everything was printed, we did all of the scribing and the details. You can see all of the things like the mooring cleats and these steel eyes, hatches, and that sort of a thing. These were all 3D printed, again, in high definition resin, embossed into the hull and then mounted flush. So a really nice finish, and of course, as you can see, a very, very unique boat. Now that you've kind of seen the outside of it, it's time to talk about the business end of the boat, and that is what's inside. So, let's take a look. Access to the interior of the hull is really easy. There is a thumb screw, stainless thumb screw, in the back here. We're just going to loosen that off, pull it out. Grab the boat from the back here, just lift up, slide back, and now everything is free. You can see we've got an air hose that is attached in here. That's a quick connect for the ballast system. So now that we've got that air hose disconnected, the entire upper hull does come off. You can see the flotation foam in there. One thing that I want to point out, that hose does attach to a snorkel valve inside the sail of the boat, and I'm going to explain the ballast system of this boat here in a moment. Since we're focused up here, I just also want to note these are all stainless steel masts and periscopes, and for the most part these were actually supplied to us by the person that commissioned it to us, and if I'm not mistaken, these are actually created from dental epoxy, of all things. I created the snorkel intake, however, out of 3D printed parts. So let's just set this aside, and we can take a look at the interior of the boat. Let's start at the stern. Now, there was a little bit of a challenge getting this to work because it, just like the Type 21 German boats, a very narrow spot back here. So we have this toothed belt that runs through, and if I just disconnect this quickly from the cylinder, I can show you how that works in practical application. Really smooth and very tight confines in there. The other thing I really like about the stern is this really unique propeller in the back there that is actually like inset into the rudder. You can see how it's all fared right into it there. Just really, really unique. This prop was carved out of a standard 5-bladed to make it authentic, and then I added all of these brass details in terms of that cylinder and everything. Huge dive planes, and they are exceptionally effective at maintaining trim on the boat. Moving forward, you can see the main drive shaft running through this nice beefy universal joint. there. Magnetic connectors, and this is a little bit different than the standard setup. We wanted to make sure that these would never come apart because it's a bigger boat with a lot of thrust. And so what we created were these catches here. So basically it's like a little saddle that these magnetic connectors click down into. So you get all of the advantages of the magnetic connectors in terms of the ease of makeup and disassembly, but it does not have the ability to come apart. Once that's in there, it's completely locked into place. So that turned out really, really good. The cylinder is an OTW dive module, 3.5 inches in diameter with a large motor option. Here you can see a test port that we put in the back. You can swap this out by adding a longer length of hose, and you blow into it to pressurize the dry compartments of the submarine to test for leaks. This boat is set up with automatic pitch control, as you'll see a little bit later on. And it also has a depth cruiser. Now, we did not elect to connect the depth cruiser, but it is still in there. It just needs to be programmed. And that has a port in here. And the idea behind it is it controls the forward servos for the dive planes, the forward dive planes, and allows you to set your depth, and the boat will attempt to maintain that based on your last inputs. The ballast tank, like I mentioned, this is a little bit different than a standard OTW dive module, which is typically sealed without this hose on the top. The reason that we vented it, we turned it from a high pressure pump system into a low pressure pump system. So the way this works, the ballast system, which is up in the front, the ballast pump, pumps water from the outside into the ballast tank. The air evacuates via this hose. Once it reaches the bottom of that intake pipe on the top of the ballast tank, no more water can be pumped in. It just gets pumped out the hose. So you end up with this small air pocket on the top, and that is your full submerged trim. Now, you can actually dive below the surface of the water, so that snorkel that we talked about earlier goes below the surface water line. So what happens when you try and surface there, you turn your pump on, the snorkel valve is closed, and the pump will draw water out, and it will create a partial vacuum from that air bubble, which will expand, creating positive buoyancy, and the boat comes to the surface. Snorkel breaches the surface, opens up, and equalizes the air pressure. Since we're here, I want to talk about the batteries. Two big, beefy batteries. These are 6 volt, 5 amp hour nickel metal hydride battery packs, wired in series for 12 volts. Power runs up to the front, connects to the boat via this waterproof connector that you can see right there. And then up in the front, you've got all your ballast components. You got a remote on-off switch up here, your main pump for your ballast system, and the solenoid for the ballast system. We removed the OTW dive control module, which is no longer needed, and we replaced it with a simple electronic speed controller. Now up in the front, you'll notice there's no servo outputs. What we've got here is a waterproof connection to the forward part of the boat, and embedded inside there are 2 waterproof servos, one for the upper dive plane and one for the lower. And if you just back up a little bit, what we'll do, we'll talk about the way that Argonaute and the Arethusa class submarines work from the dive plane perspective. It's very, very unique, similar to the German 209 submarine. So rather than having 2 planes out the side and both of them working in tandem together, it has 2 separate ones, and they nestle above each other. When the, well, actually it would be like this. When the upper dive plane extends, just one, the boat will surface, it would go back in, and then when you want to dive, the lower one comes out. And you can see barely underneath there the lower dive plane, and that one would be to dive the boat. And on the other side, on the upper side here, you can see the upper dive plane. I'm going to show you, once we power the boat up, what that actually looks like in practical application. It was tricky to get set up, but it works surprisingly well. The idea behind them is that when you're traveling through the water at high speeds, you can use those rear planes to keep yourself level, and if you don't need the front ones, they're retracted, so they're creating no drag in the water. So it's an increase in efficiency and speed. Also, no need for retractable dive planes because they're retracted all the time. So an interesting take on dive planes on behalf of our French friends. Now that we've talked about the control system, let's talk about the radio that we've got in, because I'm really excited about that. This is what we've got, and this may look a little different than radio systems that you've seen us use before. This boat, I'm happy to say, pioneered our use here at the dry docks of 900 megahertz to control an RC submarine. This is a FreeSky Horus system, and we offer them here at the dry docks now. It's running an R9M module in the back, which is going to broadcast on 900 megahertz. It has its own dedicated antenna for 900 megahertz as well. This radio, by the way, has built-in telemetry for 2.4 gigahertz. What's exciting about this is low frequency radios like 72 megahertz, 75 megahertz, and 40 megahertz for our European friends are dead. Nobody's manufacturing them anymore. The only place you're going to find them is new old stock from, for example, hobby shops that are clearing it out, or on places like eBay where you'll find them used from people getting rid of them. Personally, crystal-based radios drive me insane, which is why I was happy to adopt 2.4 gigahertz in a lot of my boats. This is the evolution, because now we've got no external antennas. You can actually see them in here in an X configuration at the top. So the antennas are all contained within the watertight cylinder. There's no antennas to go out the end caps and up the periscopes. So with all that being said, let's power on the radio. And you'll notice that this one has been set up specifically, yes, for the Nautilus dry docks with our logo in there. We've generated a basic setup program for these radios to control any standard cruciform style submarine, so you don't even need to program it when you get it. We're also going to be doing X-Tail version, but even if we didn't, programming these is so easy and fun. Now that we powered on our radio, we've checked to make sure everything is centered. I'm going to go ahead and connect power to the boat. And again, that's a waterproof connection. Our servos are already plugged in there. You'll notice nothing came on, and that is because it's on remote key fobs, just like your car. So we're going to power it up. The boat is now functional. And the other thing that I want you to notice, which is different than crystal-based radios, we've actually got a note up here, 100 dB, decibels. And this is sort of a randomly generated evaluation of the signal strength between the transmitter and the receiver. It's on a scale of 1 to 100. Because we're right next to it, it's at full 100. So you'll notice as you operate your boat, as you dive your boat, that value will change. If it gets down to about 30 or 40, that's going to be a little bit concerning. If you ever do lose communication, the transmitter will actually talk to you. It'll say, telemetry lost. And you'll know that the boat is going to go into fail-safe mode and surface itself up. So, all that said, let's take a look at the functions of the boat here. We've got our rudder. We've got our dive planes. And we've got this set up rather intuitively. So we've got our rudder on the right stick. And then stern plane override is on the side here. So pull to go down, and push to go up. Very, very intuitive. And again, you'll notice automatic pitch control on those stern planes. Throttle's on the left stick. Super, you can't even hear that. and it'll start spinning, really slowly, just with a little bit of input there. But it'll get up and move. You can listen to this. This is actually a very quick boat. I really, really like it. Ballast is on this this upper switch here, so you push it down to go down, and you pull it up to go up. Easy as that. Now we get to talk about forward dive planes, and if we take a look at it from the front here, I am going to surface the boat. So you see that dive plane extending. It's nice and smooth. It can be fast, it can be slow. After a lot of work, we got them working well. And then to dive, obviously, is the other way. You can see that on the bottom there. Like I said, surprisingly, they work rather well. I was a little dubious, I will admit. I wouldn't even have implemented them if the owner did not insist on it, but I'm kind of glad that I did, just for the experience and the coolness factor. So that's all of the functions of the boat. Now, what I'm going to do, I just want to demonstrate a loss of signal event. So if, for example, you were operating your boat, you're traveling, it's a quarter throttle like you see right there, I'm going to turn off the radio, and what should happen, the throttle should cut. The dive planes will go to surface, the rudder will center, the forward dive planes will go to surface, and the ballast tank will blow ballast. So let's see if everything is working as it should. There you go. So the failsafe was functioning properly, and again, that's basically we're simulating a loss of signal event. Boat's a long ways away, or it's really deep, loses signal, and up you come. Now, a few people might be saying 900 megahertz. That's not going to work well in water. Not like my 75 megahertz radio. Well, this is actually operating at a broadcast power of 500 milliwatts, which is pretty significant. And with that, I had absolutely no problem operating this boat out at the pond to depths of 3 to 4 feet within, say, 40 or 50 feet of my station. And I took it to 250 feet away with a sail about halfway in the water, so I could keep track of it from that distance. The decibel reading did get down to about 40, which is still very, very reasonable. Bear in mind that this will broadcast it up to 1 watt of power, which is double the power that I was using. So I have zero doubts that this is going to be more than adequate for any RC operation that you may be encountering. One more thing to note that I really, really like about this particular radio is the fact that because you're broadcasting at higher power and it may be pulling a little bit more, amperage from the onboard battery than might be normal, you've actually got an auxiliary power port right in that 900 megahertz module that you can plug in a bespoke transmission battery into. So you can make that as big as you want for all-day operation or whatever you want to do. It's a really unique feature of this radio that I really love. Installation and removal of the watertight cylinder is so easy, it's ridiculous. Like I mentioned, we're going to simply disconnect this air hose from the upper hull. Going to unplug our main power cable, and we're also going to disconnect our forward dive planes. And again, these are all waterproof connections here. So now this is completely disassembled. We're going to take our magnetic linkages apart here. And this has a super simple hold down in the back. We're just going to press down a little bit, and there's this plastic clip. We're just going to grab it, slide it backwards, drop it down in the back, and now everything is loose. Just gonna grab it, lift it up, drive shaft comes out, slide this back, and now we've got our watertight cylinder out. To install it, you just do everything I did backwards. So there you go, a unique boat of the French Navy during the Cold War era, the late 1950s and 60s. Unique profile and actually a ton of fun to build. From a performance perspective, it's quick, it's maneuverable, it's a lot of fun to drive. With a sail this size, you do get a lot of sail-induced roll at high speeds when you kick that rudder over, but once you know what to look for, it's really not an issue. With that, I am going to let you go. I really hope you enjoyed this project. If you like what you see, do like and subscribe. It helps us out at the Dry Docks a lot. If you have any questions or comments, you can feel free to drop them in the video below. But if you want a response right away, email's always the best way to get a hold of me. You can hit me up, bob@nautilusdrydocks.com. With that, I'm going to let you go. Thank you for watching, and we will catch you next time.